So now that we can see that this is going to be a different kind of titration, we're going to talk about how we're going to do the calculation. So that's what I'm going to work through you guys with this next part. Okay. All right. So, over there. So how do we do the calculations having to do with weak acid and strong base? So the maths is going to be slightly different in one or two aspects, but most of it is going to be, again, looking at what is the relationship between H and OH. So this is acetic acid versus NaOH, and again, it's exactly the same acid I was just talking about. So HAC plus NaOH goes to water and sodium acetate. Now what you're going to see me do on this practice problem and on my answer keys for the titrations is I like to write the information underneath each species exactly what's given in the problem. So I'm given 50 mils of a 0.1 mole acetic acid. So I'm going to put 0.1 molar and I'm going to put 50 mils underneath that. And I've been given 0.2 molar NaOH. So I'm going to go here. So obviously this is going to be what I'm trying to figure out. Now, you're going to have four parts to the problem. It's going to be very similar to what we did with the strong. Initial pH after some NaOH is added, equivalence point, and then some point past the equivalence point. So what is different here is, of course, this is a weak acid, so I can't just take the negative log of that 0.1. That's going to be the difference. So we're going to have to look up the Ka and do that calculation that you've done a couple different times. So that's going to be x squared over 0.1 minus x, and we're just going to cancel out that x. So then x comes out to be 0.0013 moles of H plus, molarity. So if I take the negative log of this, my pH is going to be around 2.870. Again, 3 sig figs are going to be digits after the decimal. So again, this is very different from your strong. Your strong, if you had a 0.1 molar HCl, you would have a pH of 1. So that is another difference that you find with this curve, is where exactly are you starting. It's going to be a much higher pH than you do with strongs. All right, so then we add some NaOH. So I'm being not specific with my amount of NaOH because this is what we call the buffer region. And that is because you are starting to make the other ion that is either acidic or basic. So in this case, what I want you to focus on is not the math part, but what's exactly in the flask. So that's going to be the focus for this. So in my flask, the majority of what's in there is going to be the acetic acid, so HAC. I am going to see a little bit of H plus and a little bit of acetate as I've done before. But once I start to add the OH minus, what's going to happen is the concentration here of my acetic acid is going to go down because that OH is going to be removing that from the situation. That H plus is also going to decrease. But what is interesting is, since I am ripping off that H plus from that acetate, this concentration is actually going to go up. Okay, so H plus is going down, HAC is going down, this is going up. So that is where we can do pH is equal to pKa plus the log of your acetate ion over your acetic acid. The AP has decided that they don't want you to do the calculation with this. Instead, we're going to focus on what species are in there, what is happening to the concentration of everything that's going on in there, which is probably a little more tricky question. So the other point that is very interesting is what we call halfway to equivalence point. And so that is going to be on your graph here, okay, is where you have added half of the acid that you're supposed to, okay? So this is what we call the halfway point. This is called the halfway point, okay? And it's an interesting point because it's going to equal pKa, okay? So that's going to come back. You're going to see how that is relevant. So this is equal to your pKa. It is half the volume of the base you need to completely neutralize. So again, this is 50 mils of a 0.1. I have a 0.2. So obviously my equivalence point is going to be somewhere around 25 milliliters. Okay. So there's no difference here if this was strong or weak. It's always going to be, again, that OH is ripping off that H plus. So if I have half the volume of base, in theory, I have 12.5 milliliters of NaOH in this problem, okay? Why that is so significant is because you're going to have essentially half of the acetic acid is going to be neutralized, and you have produced half of your acetate. Well, that comes out to be a 1. So we know that if we had our Henderson-Hasselbalch equation, if this is a log of 1, that becomes 0, so pH is equal to your pKa. Okay, so this halfway point, your halfway point to your equivalence point, I will ask you to calculate that pH because that's very easy to do. Okay, so realize we are neutralizing half of the AC, and I am producing half of the acetate at this point. So that's why this is such an important point for chemists. So I'm going to stop there for this video, and then we will finish the rest of the problem.